This video is for 14.2 P2. In this video I'm going to go through one of the preliminary tasks for P2. It's the investigation of the relationship between the mass of gas and the gas temperature at constant pressure and constant volume. So I'll be using the preliminary task which is available on Moodle, so make sure you get that and work through it. In the task you're given some data and you have to use that data to find out whether the mass and temperature are directly proportional or inversely proportional. There'll be one or the other, not both. So that's the first thing to do. That's saying we have to find out whether it's directly or inversely proportional. Then, once we've done that, we will state the relationship between mass and temperature once we know which one applies, and then for 3 we apply. In the application stage we'll have to write a number of statements which are how we would get back to normal operating conditions after a change to some of the gas properties. So let's start off then with part 1, where we're going to look at the data and investigate whether mass and temperature are directly or inversely proportional. So the data on Moodle on the handout gives us mass, temperature. This is in grams, this is in Kelvin. That's the table of data that's given to us. Firstly, we're going to, let's write this as A. We'll do the test for direct proportionality. Now, what you have to do in this one is you have to see if, or does mass divided by temperature stay constant? Right, we'll produce another table here which is going to just have one column, mass divided by temperature, and then we'll calculate that for each of those values, put them there, and we'll see if they're constant. So I've already done the calculations, and you can do them yourself. That's what I recommend you do. 0.00. Check that you get the same ones as me. 0.0038, 0.0040, 0.0042. Okay, so does it stay constant? You can see that the values are all going up. 0.0037, then 38, then 40, then 42. So no, this is our conclusion then. Mass divided by the temperature is not constant. Therefore, mass is not directly proportional to the temperature. Just going to rewrite that. Okay, so I've said quite clearly it is not directly, mass is not directly proportional to temperature. Right, part 2 then. We do the same thing, but this time we're testing for inverse proportionality. I'm writing abbreviations, but you should write out full sentences when you're doing your preliminary and then when you come to the final task as well. This time the test is does mass times the temperature. I'll actually write in. Okay, so produce another table with mass times temperature. Work out the values for each of those. So we get 270, 270. These are all to 3 significant figures here. This would actually be 0.3, 0.4 and so on, but to 3SF they are all 270. And we can see quite clearly that they are constant. So the mass times temperature values are all constant. Therefore, mass is inversely proportional to the temperature. So that was our conclusion. For one test, the mass was not directly proportional to temperature. For the second test, the mass is inversely proportional to the temperature. So that's our test and conclusions. So now that we know which one it is, whether it's inverse or directly proportional, we can state that. So let's get rid of this table of data. We can say that mass is inversely proportional to temperature at constant pressure and volume. So you need to state that relationship fully with the constant terms there as well. So we've now done 1 and 2. Lastly, we need to apply it, and there's some statements we need to write for that. I'll just rub off these bits here. Now these statements we can only answer because we know what the relationship is. We're going to use that relationship to solve the problems. So let's do this then. Although this is part 3, on the preliminary it's actually question 4, so I'll write that up as question 4, and that would be 3. Just so you can keep track of it on the handout. Right. A. In statement A, we are told that the pressure increases. So something has caused the pressure increase in our gas storage tank, and that causes the temperature to increase. At this stage we haven't answered anything, this is just what the question tells us. Here comes the question. To return the temperature to its normal value, what must happen? It must either increase or decrease. Now the temperature increased, so we need to do the opposite to that. To return to normal, the temperature must do the opposite to that, which is decrease. Okay, so that's the first one we need to get right. Then we need to do some kind of change to the mass of the gas in order to achieve that decrease. And this is where we bring in our relationship here. So to decrease the temperature, we need to, because it's inversely proportional, we need to do the opposite to that. So we need to increase the mass. Sorry? Yeah, we must increase. So to decrease the temperature, we must increase mass of gas in our storage tank. Okay, so that's the second point at which we get a mark if we get it right. How would you increase the mass of gas in the gas storage tank? You pump more gas in. Okay, so those are the 3 points where we would achieve marks because we're answering the question. Okay, and we knew this is because that's where we brought in the gas law, the gas relationship. Okay, that's what you need to do. So you go through it logically, you need to write out the whole statement and include these logically correct statements there. Let's do one more, which is B. So we'll do that over here. This time, the pressure of the tank decreases. Something happens, decreases the pressure, and we're told that the temperature decreases as well. Oh, actually that's not something like. So that's what we're told, temperature decreases. We need to get back to normal temperature. What must happen to the temperature if it's going to return to normal? Well, the temperature decreased, so we need to increase the temperature. Just as before, we need to do the opposite to what happens. So the temperature increased there, we need to decrease it. Temperature decreased here, so we need to increase it. How do we use this relationship to achieve that change? So to increase the temperature, what do we need to do? It's inversely proportional. So we need to do the opposite to that. We need to decrease the mass of gas. And that means gas needs to be pumped out. Of the gas storage.